Hi class, so for this video we're going to go into some dimensional analysis problems that are actually two-step equations. We know we have a two-step equation when they're asking us to go from molecules, particles, or atoms to grams. So grams, moles, atoms, that is telling us that we have a two-step equation. So to set it up really quickly, guys, I want my given and my wanted. So they're giving me, remember your given is always a number, they're giving me 35 grams of water. And they want me to find molecules. So molecules, particles, formula units, all of those are the words for atoms. So I know using GMA that I'm given grams and they want me to go to atoms. So this is a two-step equation. So for two-step equations, that means you have two conversion factors from grams to moles and moles to atoms. The first one that is super easy is moles to atoms because it's always 6.02 times 10 to the 23 atoms. The second one is 1 mole. And I'm going to have to put grams of water. Again, where do I find this number? I go to the periodic table. For this one, I just provided it just due to time. So when I add it all up, I add 1 oxygen and 2 hydrogen, 16, 17, 18. I get 18 grams. So from here, guys, I just set it up. I put my given, which is 35 grams of water, across to cross out. So from my conversion factors here, I need to find the one that says grams. So here I have 18 grams. I will put 18 grams of water. I have to put what was on the other side, so I'm going to put 1 mole of water. Again, I have one more conversion factor. I need to cross to cross out, so I would use 1 mole again so they can cancel out. And then I'm left with 6.02 times 10 to the 23 atoms. I just plug it into the calculator. I would multiply across and divide. 18 times 1 is 18, so I would have that on the bottom. And then I would have 35 times 6.02 to the 23rd power, which gives me a exponent 2.12, around 2.12 times 10 to the 25th divided by 18. And I should get something around 1.17 times 10 to the 24 atoms of water. These are not difficult, guys. You're just doing one little extra step. You can put me on pause. You can try this next question on your own. How many grams are in 3.54 times 10 to the 24 molecules of sodium? Okay, guys, so let's solve it really quickly. We know we have grams, moles, and atoms. My given and my wanted. My given is 3.54 times 10 to the power of the 24. That's what that little thing means. Atoms of salt, NaCl, and they want grams of salt. So I know that I'm going from atoms to grams. This is a two-step, right? This is a two-step problem. So I know that I'm going to have two conversion factors. My first one is super easy because I'm working with atoms. I know 1 mole equals 6.02 times 10 to the 23 atoms. On the second one, I know I need the mass because I'm going to grams. 1 moles equals blank atoms of NaCl. I would go to the periodic table, add 1 sodium and 1 chlorine. Here, I put them for you just so it's a little bit easier. So we would add up 23 plus 35 to give us 58 grams. So again, guys, I have what I need. I have my conversion factors. Now I just need to plug in and solve. I start off with my given, 3.54 times 10 to the 24 atoms of NaCl. Across, I need the atoms as well, so I would plug in 6.02 times 10 to the 23 atoms. On top, I had 1 mole, so I'll do the same thing. I need the same across. So I need 1 mole, and then lastly, 58 grams of NaCl. From here, class, all you have to do is multiply across and divide. So when I multiply this across, 3.54 times 10 to the 24 times 58, I get the value of 2.05 times 10 to the 26, right? And then I'm going to divide that by 6.02 times 10 to the 23. And your final answer should be something around 341 grams. Again, because it is asking for grams, you're not giving grams and exponents, so this answer makes sense. Hopefully this helps, guys, and study, study, study.